Okay, dear students, last lecture we have studied this started introduction of the algebraic functions. So that are what are the different types in algebraic function and some methods of factorization, rules of indicization which are used for algebraic function and exponential function. Now today we will see this how we factorize cubic and higher degree equations. So factorization of cubic and higher degree equations. So first method for this cubic equation is the method of grouping. So when we go to the factorization of cubic and higher degree equations, so first of all, you think about the method of grouping because this method is less time takes for the factorization. So we'll take with the example, suppose how this method of grouping. So for example, suppose if you consider x cubed plus 3x squared plus x plus 3 equal to 0. Now you want, if you want to factorize this, whether this grouping is possible. So yes, here grouping is possible. So you from first two terms we take x square common outside, x plus 3 plus here 1 is common, so x plus 3, not essential to write the 1. So when not written, 1 is there. Now here this common factor is coming. So when common factor is coming in by grouping, so we are using the grouping way. So x plus 3 is one factor and other factor is x square plus 1 is equal to 0. Now x square plus 1 complex factors, x plus I, x minus I, etc. But in maximum applications, our requirement is the real factor. So these are the factors. So this is about the method of grouping. Suppose we consider second example, x raised to 4 minus 16. Now when you want to find the factor of this, we can write x raised to 4 minus 2 raised to 4. So that is equal to, now this is nothing but x square, square of that, minus 2 square of that. So x square minus 2 square and x square plus 2 square. So that is equal to x minus 2, x plus 2. Now these are not imaginary factors are coming actually. So we will keep this as a x square plus 4 factor. So for real factors. And other method is we can use the formula. So maximum we are using this method, but a lighter method is there, alternative method. So x raised to 4 minus 2 raised to 4, 1 factor x minus 2, that formula which we have studied, x raised to minus a raised to, that formula will apply here. So x cube plus x square into 2 plus x into 2 square plus 2 cube. So x minus 2 x cube plus 2x square plus 4x plus 8. So like this, we will factorize this. Next, again the grouping method here we can use. So x minus 2. Now if we group the first two terms, x square will take outside. So x plus 2. If we take 4 outside, x plus 2. So common factor is coming here. So x minus 2, x plus 2 and x square plus 4. So we can factorize like this or like this. Actually this is the our choice or selection must be this method because steps are minimum, time required is minimum. So in engineering, I have told what is engineering. So engineering means value with productivity. Value means quality of performance, result, accuracy must be obtained, but that within minimum time. Within time, then you will be in competition, otherwise you are out of competition. Even though your quality of performance is okay, but you will not achieve the productivity, then you are not held in the competition. Now second method, synthetic division method. So with example, we'll understand in this. Suppose you consider x cube minus 6x plus 4 equal to 0. Now for this example, if you want to factorize this, the method of grouping is not possible here. So first of all, you search the function. Suppose this is the polynomial p of x is equal to x cube minus 6x plus 4. Now if we find p of 0, so that is coming 4, not equal to 0, meaning of that x is equal to 0 is not the root of this polynomial. P of 1 we will find, suppose, so 1 cube minus 6 into 1 plus 4, so that is equal to 1 plus 4 is 5 minus 1 not equal to 0, meaning of that x is equal to 1 is also not true. Then P of minus 1 if you find, minus 1 cube minus 6 into minus 1 plus 4, so that minus 1 cube is minus 1 minus plus 6 plus 4, so that is 9 not equal to 0, meaning of that x is equal to minus 1 is also not root of the equation. So P of 2, so 2 cube minus 6 into 2 plus 4, so that is equal to 8 minus 12 plus 4, this is coming 0, therefore x is equal to 2 is root of equation. So like in this way, you first of all find the smallest, maybe positive or negative, root. Now we will do the synthesis. So you write the polynomial, if any term is missing, you take the coefficient 0 and write the term. Now here x square term is absent, you write 0x square minus 6x and plus 4. Now here one root, we know this x is equal to 2. Now we take the coefficients 1, 0, minus 6 and 4. Now here you take 1 here, multiply this. 2 into 1, that is 2. Do the addition here. So 2 plus 0 is 2. 2 into 2 is a 4. Minus 6 plus 4 is minus 2. Minus 2 into plus 2, that is minus 4. So 0. So this is a remainder. So remainder is 0. Now here we are getting, this implies x cube minus 6x plus 4 is equal to, x is equal to 2 means factor x minus 2. And other factor, this constant, you multiply here x and x square. So x square plus 2 into x minus 2. Now this is the quadratic. So by quadratic equation method, you think for the factors. So 2 factors is 2 into 1. Here plus 2 is required, here minus. So plus 2 and minus 1 not fitting. So this is the factor. We are not getting the factor. To find the factor, you want to use the completing square. So that is also not applicable in higher level examples. So these are the factors we will consider, and then we will do this. What is our requirements? Now next we will understood some expansion formulae. Now for expansion, basic rule is the binomial theorem. So we understood about the expansions. So for expansion, binomial theorem. So x plus a raised to n is equal to x raised to n plus nc0 nc0 x raised to n plus nc1 x raised to n minus 1 into a plus nc2 x raised to n minus 2 a square and so on dash last term ncn a raised to n. So this formula is applicable for n belongs to capital N. Now here this formula we can write as x raised to n plus n into x raised to n minus 1 into a plus n. This is the fact NCR formula we are actually expecting for. So NCR n factor upon n into n minus 2 factorial. So NC2 n minus 1 upon 2 factorial x raised to n minus 2 a square and so on dash plus a raised to n. So this is we use for any real power, positive, negative, etc. So by this binomial theorem, we can get the expansions of suppose x plus a square. So x square plus 2ax plus a square. X minus a bracket square, we can write the expansion x square minus 2x plus a square. X minus a bracket cube, we can write this expansion as x cube minus 3ax square plus 3a square x minus a cube. X plus a cube x cube plus 3ax square plus 3a square x plus a cube. For higher powers, use this theorem and directly you will find the expansions. Now when the three terms are there and if you want to find, suppose x plus y plus z bracket square you want to find, so we will take two terms as a one term. So x plus y plus z bracket square. So that is equal to x plus y bracket square plus 2x plus y into z plus z square. So now we expand this as x square plus 2xy plus y square plus 2xz plus 2yz plus z square. So that is coming in standard form x square plus y square plus z square plus 2xy plus 2yz plus 2zx. So in this way we can find the expansions of the functions. Now next we will understood about the partial fraction, that concept of the partial fraction is useful in integration. Partial fraction. So the partial fraction in application is required as a proper partial fraction. Actually, two types of the partial fractions. One is improper and the other is the proper. So improper is not useful in applications. In application always the proper partial fraction is required. So we will study the proper partial fraction. So for proper partial fraction, so condition is there. So what is the condition for partial fraction? So degree of numerator n means the numerator must be less than degree of d, that is the denominator, if not divide n by d. So you divide the numerator by denominator, you want to take the actual division and then you will do the partial fraction. Now different cases are there. Suppose we will assume this degree of numerator is less than the degree of denominator. So cases, first case, case first. Suppose p of x divided by x minus a, x minus b, x plus c, like this. So here, new degree of denominator is x into x into x, that is x2. The degree of denominator is 3. So p of x degree must be less than 3, maybe 2, maybe 1, maybe 0. Then, now here the factors are linear factors, not repeated. So we take the arbitrary constant of 0 degree, that is a upon x minus a plus b upon x minus b plus c upon x plus c. Now case second, suppose degree of numerator is less than degree of denominator, and here some factors are suppose x minus a, x minus b square, x plus c cube, like this. So here factors are linear, but the second factor is repeated twice and third factor is suppose repeated thrice. So in this case, how will take the partial fraction? So a upon x minus a plus, now this second factor repeated twice, we will take two constants. So b1 upon x minus b and plus b2 upon x minus b bracket square plus c1 upon x plus c plus c2 upon x plus c square plus c3 upon x plus c cube. So in this way, we will take the partial fraction. Now case third, p of x divided by, suppose the factor is in quadratic form, ax square plus bx plus c, and here the factors are not possible. If factors are possible, you convert this factor in the linear. If linear factors are possible, you factorize possible. So we are assuming here this is not factorized as the real factors, and x plus t suppose. So here, as this is the second degree factor, we will take arbitrary constant as first degree, that is linear. So ax plus b divided by ax square plus bx plus c, and plus this is the linear factor, so c upon x plus d. Fourth possibility, suppose p of x divided by ax square plus bx plus c bracket square into x plus d. So in for this case, now here this quadratic factor repeated twice, so we take here a1x plus b1 divided by ax square plus bx plus c plus a2x plus b2 divided by ax square plus bx plus c bracket square plus c divided by x plus d. Case fifth, suppose sometimes examples are in this form, x square upon x square minus a, x square minus x square plus a, x square plus b, like this. Now here all the terms are x square, means here we are put x square is equal to t. So this example is converted to this form, t upon t plus a, t plus b. So now these linear factors, so a upon t plus a, first case, b upon t plus b. Similarly, instead of x square, any type of the function is there, suppose e raised to x divided by e raised to x plus a, e raised to x plus b. Now we put here e raised to x is equal to t. So this example is t upon t plus a and t plus b. So that is equal to the first case a upon t plus a plus b upon t plus b. So these are the different cases how we will take the arbitrary constants. Now to find the arbitrary constants, so first priority is method of substitution and second is the comparing coefficient. So find arbitrary constants by method of substitution. And comparing coefficients. So method of substitution means what? So a upon x minus b. So to find the value of a, you put x minus a is equal to 0, that is x should be b upon x minus b here. So put x is equal to b, so we will get the value of b. For that, you want to first take a simplify it. You take the LCM and p of x is equal to write the equation. Denominator gets cancelled. Actually, LCM of this is this. This gets cancelled. So we get the equation. In that equation, you want to put this denominator value is equal to 0. We are getting the constants. And now in this type of the cases, only substitution is not possible. Actually, in some diploma books, etc., they are new books. They are given only the substitution. तर आम्ही म्हणतो त्याला काय दादा तुमच्यासाठी काय करू. So actually that is not proper way. Any value we are putting, that is we are getting the equation, then you solve that equations. That is the time consuming method. That is not engineering method actually. So for to solve the example minimum time, to find values in the minimum time, this method is very important. Compare the coefficients, left hand side and right hand side must be equal. That x cube coefficient must be equal, x square must be equal, x coefficients must be equal, constants must be equal. So by that way, very easily in the minimum time, very minimum time, very much time we are saving this in this method, comparing coefficient. Actually, this how this calculation part is done, that we'll see in actual applications when we'll go to the integration, etc. Integration by partial fraction, or in engineering, Laplace transformations, etc. Their transformation, their partial fraction is required. So this is about the partial fraction. Now next we'll understand about the numbers. So that is also the important part in algebraic functions or in mathematics. So you know this the numbers which are using in the mathematics basically classified into two groups. One is the real numbers, other is the imaginary number. Now real number, so any number, this value which has the value, suppose for example 2, 0, minus 2 by 3, 4 by 5. So all these numbers, I also this suppose root 2 plus root 3, all these are the real numbers. Now if any x is the real, so x we can say x belongs to R. X belongs to R means x is the real number. Imaginary number that we have studied is the complex number, so denoted by I is equal to root of minus 1. Now here, when we do the combination of this real and imaginary number, then the number will be formed, that is z is equal to x plus iy in this form. This number is the complex number. So complex number means the combination of real and imaginary numbers. Here x and y both belongs to R and I is imaginary number. Now real number further classified into different groups. So rational numbers and other is irrational numbers. So rational numbers means any type of the minus 2, minus 1, 0, 1, 2, 3, suppose minus 4 upon 3, plus 4 upon 3. This type of the numbers are the rational numbers. So if any x is a rational number, x belongs to Q. Q is the set of all rational numbers. Now irrational numbers means root 2. Root of the prime numbers is the irrational number. Root 2, root 3, root 5. So these are the irrational numbers. Now if we do the combination, grouping of these two numbers, the number will be formed in this form, p plus root q. So this is the search. Search means the combination of real and imaginary, rational and irrational numbers. Now these rational numbers further classified into different types. So one is integers or whole numbers. So x belongs to z or w, that is the integers or whole numbers. So which are the whole numbers? So -2, -1, -0, 1, 2, 3, etc. These are the integers. Now next, integrals. So integrals we can write as x belongs to I. So which numbers? 0, 1, 2, 3, etc. These are the integrals. Now next type, natural numbers. Natural numbers. Now set of all natural numbers. So x is the natural, means right, x belongs to n. So which are the natural numbers? So 1, 2, 3, 4, etc. These are the natural numbers. Now even integers, even numbers. So x belongs to E, suppose. So 0, 2, 4, 6, 8, etc. These are the even numbers. Odd numbers. So x belongs to the O, odd numbers. Which are odd numbers? So 1, 3, 5. That is the numbers which are not divisible by two odd numbers. Number divisible by 2 are the even numbers. 7 and some dash even. So in this way we can classify the different types of the numbers. So this is the revision for algebraic function. Now next period we take the revision for trigonometric functions.